Hey there, Foppers, and welcome back to our quest to finish every single video game. That's right, absolutely all of them. Today we're going to be trying out A equals B. I have basically no idea what this is, so we'll just figure it out. Anyways, we have like a main menu here, so A equals B, and we're gonna enter compiler principal course project late submission to Professor. Hello, Professor. I am a student in your compiler principal class. Sorry, I missed the deadline for a class project submission. The reason is, according to the class project document, a student may choose not to use the given framework and implement a compiler of their own. Then I decided to take a further step, create a compiler for an original programming language. Since this goal was more difficult to accomplish than expected, I exceeded the deadline. I hope you can understand. Course report.pdf. Okay, so we don't need that. Not for now, at least. And this is the first puzzle. So 1 to 1, A to B. A string of A, B, and C. That's the input. Replace each A with B. And the program seems to be done for us. So yeah, so we write a script here to change the left side into the right side. So this will just look at every A, if I understand correctly, and it will turn it into a B. So it's already done for us, so we can just do play there, and that works out. Yeah, which is here, we can speed that up. Cool. And we did the extra challenge, of course. The game solved itself. Accepted. Okay, then we can do. What can we even do? Oh no! Oh, that opened something. Okay. Well, let's not worry about that. Let's just leave. Okay, so reply. Compiler principal course project late submission. From Professor. You call this a programming language? 1-2 uppercase. Okay, so input a string of A, B, and C and replace each letter with its uppercase. Constraint 1 to 7 input length. So we can do lowercase a is equal to uppercase A. We can do lowercase b is equal to uppercase B. Lowercase c is equal to uppercase C. And that should finish every single puzzle for us. Easily. Yeah. At most 3 lines complete. So there doesn't seem to be a shortcut here. There's no like for loop or anything in this programming language. Cool. 1-3 singleton. A string of A, B, and C. Output replace consecutive repeated letters with a single letter. Yeah, so now I might have to look up the log for this, because if you do A is equal to A, for example, and we could do B is equal to B. Come to think of it, I wonder if it just repeats the code until it's satisfied, maybe? Does this work? Accepted. Yeah, so it just, for any string, it just repeats the code until it's satisfied or impossible, I guess. I guess. I'm not quite sure. But it did work, so we're fine with that. And almost 3 lines was done, so it's all good. Singleton 2. Input a string of A, B, and C. Output remove consecutive A's. So that should be the same thing, only we should do A is equal to just nothing, I would think. But how would you? I guess we do A is equal to A first. Oh no, yeah, we do A is equal to A. Huh. Well, what if you first do A is equal to D? Because D will never be in these original strings. Huh. Well, that won't really work. That will change every A. No, we don't want that. Huh. How would we remove every consecutive A? Because what I'm thinking is, if the input is ABC, the A isn't consecutive. We don't want to remove that A. So if this is input is equal to ABC, we want out to be ABC. But if we have in here is equal to ABC, then we want out to be ABC. Or, I mean, BC. Yeah. And where we get an issue here is that if we say AA is equal to blank, then if the input is AAABC, the output is going to just be ABC. I think. I think so. So how do we avoid this issue? Well, if we instead did, what if we did a check for odd numbers first? So let's do AAA is equal to nothing, and then we do AA is equal to nothing. Would that work? Because say there are four A's. Well, this would I mean, we could have a ton of these. We could do AAA. We could do this. We could work our way down all the way from 7, since we will never have more than 7. And we could do this. And this is definitely going to work, but I doubt this is the least amount of lines possible. Let's just see what happens now. Hmm. Ah, I get it now. So it goes from top to bottom. I misunderstood how this language works entirely. It goes from top to bottom, and once it hits something, it redos. It redos itself. It does not keep going down. It completely undoes. Which is interesting, and I think that's relevant to how to solve this puzzle. And then if it ever passes through with no changes, then it's done. Let's see, at most 2 lines, so this isn't exactly a good solution. And I totally get that. I totally get that. So, what can we do? With 2 lines? How's that supposed to be possible? Hmm. I'm curious if I need to read the instruction manual because there's not enough tutorial in the game. I'm gonna do that real quick. Okay, so there was nothing at all that was missed in the documentation. We do have all the information we need. We do. And there doesn't seem to be anything of importance I've missed in the challenge description either. But what I did notice is it tells us, well, it, there seems to be very few situations where you have more than 3 A's. So I'm wondering if it can never be more than 3 A's in the input for whatever reason. I'm just curious. Okay, so there are more than 3 A's sometimes. Are we getting the issue with this then? Because if there are ever 4 A's like here, it will remove 3 of them and then let 1 remain. And that will not be removed. So how do you avoid that with only 2 lines of code? That seems impossible. Yeah. What if we convert AAA into AA? Then that will get deleted here. But if we have more, if we have 4 A's, then that will be converted down to 3, and then 2, and then deleted. Oh, that's totally the solution. Oh, that's genius. Okay. Okay, that's beautiful. Perfect. So, we get an answer again. By definition, A equals B is a programming language, and the document didn't restrict what language I can choose. 1-5. Sort. Again, A, B, and C. Sort the input in alphabetical order. So, if we ever have C, A, B, A, want it to be A, B, C. I know of a way to do this with a lot of lines. I mean, the obvious one is to say we never need to we need two letters in a row, right? So we can say, for example, if we have BA, that's going to equal AB. And if we have CA, that's going to equal AC. And then CB is going to equal BC. Now, I wonder if there's a way to do this with two lines. First of all, we don't need the AB equals AB counterpart, obviously, as already alphabetical. Same with AC, same with BC. We only need the ones that are not alphabetical in this program. And this will just keep running until it's sorted them. So this alone should work. It should work. Now, I am wondering, do we need a CA? Well, say we only have C's and A's, of course we need it. If we don't have a B, and if the input is just CA and we don't have a B in the string, of course we're going to need CA to disambiguate that. I think this is the least amount of lines possible. I think this should be doable. That's very doable. Perfect. Then we can do 1-6, compare. Okay, so inputs are only A's and B's this time, and output is the most common letter. The number of A's and B's is different. It's never gonna be the same. Now, how would you do this? I mean, an obvious start to me is to say AB equals, well, nothing. Because what you're really doing is you're taking, in the input string, you're taking one A and one B, and you're removing one of them, and then you're left with the remaining B to get B. Same here, you remove one A and one B, and then remove one A and one B, and you're stuck with an A. So you're not actually counting, you're just deleting for empty space. Now the issue here is, well, it's not an issue if you have multiple letters in a row, is it? I guess there is one thing to consider, and that is if we don't have one more B or one more A, because there are only two letters, okay? So if we have an A and a B in the puzzle, they will always be next to each other at some point in the string. So if we do AB equals blank and then BA equals blank, that will always remove every single instance of them next to each other. And what we're gonna be stuck with is a string that does not contain any more than one letter. Now, if we had one A and 5 Bs, we'd remove one A and one B and still be stuck with 4 Bs. And therefore, we're going to need this little fellow here. And that's going to take the number of same letters down until we reach 1. Because remember, it repeats, it loops around. So if you have 3 A's, it will just run this twice and we'll be stuck with 1A. After 1A, none of these will trigger anymore. So this should work, and I think this is the minimal amount of lines possible. Let's have a look here. Yeah, perfect. So we did it in almost 4 lines. Cool. Now we can go to the response here. I have to point out, your so-called programming language can't even output hello world. It is unable to perform any of the tasks required by the scoring criteria. We're gonna prove him wrong, aren't we? Now A equals B can output hello world. The title says it all. Okay, I might have to read this one. 2 seconds. Okay, so we have unlocked a new feature actually, and that feature is keywords. I don't know if there are multiple keywords yet, but I know there is one, which is return, and we can see that here. So what return does, it ends the script. So down here, if we had hello world equals A again, if we don't have the return, we're going to have an endless loop. It will first change the A to hello world and then the hello world back to an A. And we can see that here, right? Look at this. This will just keep on going. And even if we speed it up, it will just keep on going without ever stopping, right? We're still in test case 1. It's never going to stop. Now what we can do now is we can say return, and that will end the script when we do this line of code. So now if you test it, we can see we're done with test case 1, right? And also it will change the entirety of the output, this return. So the return will just say this is the new output string and that's it, right? So even if we have A, B, C, the output of A equals return hello world will be converting the entire string to hello world and say that is the output. Okay, so we can just play this test scenario. Okay, that doesn't work. So we want to copy this. We want to copy this 3 times, probably, and just say B and C. Of course, since not every string is going to contain an A. The tutorial here tricked me. Okay, but this will always work as long as there's an input string, and it has to be an input string because it has minimum size of 1. Yeah. This is going very slowly. It is working, but it's going very slowly. Huh. Why are there so many test cases here? Okay, there we go. At most 1 line. Can you do empty string is equal to hello world? Is there always an empty? Yeah, there's always an empty string. Well, this is a funny solution. It's probably not gonna be relevant ever again because it's like that would be the exact same puzzle, really. Just always have an output string no matter what. Which makes no sense to have another one of these puzzles. But it is funny that you can just do that, and it's useful to know that well, if you just did empty something, it will always if you didn't have the return, it would always add another empty here, so it would never end. Okay, so that's never going to be a solution again. Are you trying to make me laugh? Yeah. Triple A. Input. A string of A, B, and C. Output. Return true if the input contains at least 3 A's. Otherwise, return false. And this is quite simple, because this takes what we really know. So what we're going to do first is just say A equals, and then return true. So if you have an A, we'll just output true and end the program. And if we don't have an A, we can do empty. And it's actually relevant again immediately, because we have something else on top, of course. But we can do empty return false. So if it finds an A in the string, it will just immediately return true and end the script. And if it doesn't find an A, we'll go here and it will immediately return false and just end the script. Huh? At least 3 A's. Oh. Huh. Well, that's strange. What we can do here is we can definitely do this. We can do B equals nothing, C equals nothing. This will cleanse the string, remove all B's and C's to get just the A's. And if we have at least 3 A's, it will return true, right? So this test case, if there was an A at the end, the program would first remove the B's and then the C's. We would have 3 adjacent A's, which would return true. But in this scenario, since there are only 2 A's, we'll only end up with 2 A's in the final string. meaning it returns false. So we can do this, and this should solve it for us. And it is the most lines for the challenge, so that's good. Exactly 3. This is going to be the same, but for exactly 3, isn't it? Return true if the input contains exactly 3 letters. And we can do this in a similar way, kind of. So first we're going to want to cleanse the string again, because we can't work with different letters. What we're going to want to do is convert every string into A then, for example. So we do B is equal to A, and then C is equal to A. So for this test string, the B would be A, and the C would be A. We have 3 A's, which makes it easier to do something, because then we can do A is equal to return true. So if we have A, it will return true. And the reason we have to do this is because there are so many combinations here. It will take a lot of lines to test for all of them. It's possible, but it's more difficult. And definitely not going to give us a challenge. Like ABC is equal to return true, but it could also be CAB, and then we need a separate line to say CAB is equal to return true, and we need this for every variation. Now, there is one more thing to think about here, and that is, well, it's two things to think about, really. So we're gonna want the same thing as last time here, which is, if it runs past this line and it's not returned true, we're gonna want to just return false, because then it has 2 or fewer letters. That's the wrong way to use keywords. Return false. But we also want to check if it has 4 or more letters. And the way we do that is to just have this line. So, if we have 4 or more A's, really, because if there are 6 A's, this will still trigger, it will return false. So this should work, I think. And I think this is the least possible lines. At most 5 lines complete. So this is the optimum solution here. At least the optimal intended solution. Okay, 2-4, remainder. A string of A, B, and C. Divide the input length by 3. Output the remainder. Oh, okay. So, again, we will want to cleanse the string to make it easier to work with for us, I think. So let's work with A's here. So let's do B equals A and C equals A. And now, what we want to do is... Yeah, there are no for loops or anything. What we want to do is, if we have 3 A's, that will just equal blank. And that will keep looping. And then we'll end up with the reminder, which is either 1 or 2 A's left, because then this wouldn't trigger, or 0 if the string is empty. And we need to change the entirety of the output string to be 0, 1, or 2 based on those scenarios. So you can do AA, that's if there are only 2 A's, will be equal to return, and then 2, because we need to tell the script that it's 2. And we can do the same here, return 1 if we have 1A, and then if the script is just blank here, or the string is just blank, we'll just return 0. It can obviously never be 3, because that will get removed here, that's not the reminder. It can still be divided by 3 and go down to 0, you know? So we can do this, and I think this is optimal. It is, and most 6 lines. Yeah. So, for the sake of my sense of humor, can you lower your standards a bit? 2-5, odd. Input, a string of A, B, and C. Output, return true if the amount of each letter is either an odd value or 0. Otherwise, return false. Hmm. So now we need to worry about the amount of each letter. How will we do that? I think we want to sort alphabetically again, probably. That's going to make it far easier to work with if we have big strings. So I think we want the three we had, the CA is equal to AC, the CB is equal to BC, and the, what was it, the BA is equal to AB. And this is going to alphabetically sort the string as we did earlier. So we're familiar with that. And then we are gonna want to remove odd numbers from the equation here somehow. And I think the way we would do that is huh, odd value or zero. Zero is an even number, so we need to be aware of that. So we keep track of that. Because I'm thinking if we do A, for example, and we can just say that is equal to A to simplify it down, we're taking an odd number and making another odd number here. And that will keep happening. Afterwards, we can just say AA. So, if, yeah, this will work. This will work. Let me just type it out and I can try to explain it to you. If we have AA, we return false. And we're going to want to do this for every other letter too. So what we do is AAA is equal to A. That will take any odd number of letters of A and it will simplify it down to only being one A. Right? So say we have 5 A's, it will run this script and we'll end up with 3 A's. It will run it once more and we'll end up with exactly one A. Right? If we ever have an even number, those numbers will just be plus 1. So 6 will be converted down to 4, and then it will be converted down to 2. This wouldn't run anymore, it will go here and would return false, which is accurate because that's an even number. And it will be simplified down to either 1 or 2 or 0 A's if there are no A's to begin with. Right? So whether we have 0 or 1A left, it will just skip this line and go onwards to the next one. And we're going to want to do this for every single letter. So we can just copy this to 3 there. Then we can do B. This will just be the exact same. And this is why we wanted to sort it alphabetically. Afterwards, we just return true. Because obviously if we reach this end, we have sorted and simplified down. We have no occurrences of 2A's, 2B's, or 2C's. No 2A's, 2B's, 2C's in the original input. We can just say it's true because we know that for a fact. This should work. Is this the least amount of lines though? It is. Incredible. It feels like so many lines, but I guess the puzzles will just keep getting more complicated. 2-6, the only. String or input of A, B, and C. Return true if exactly one letter is different from adjacent letters, otherwise return false. For example, in string B, A, B, B, C, first A and first B are different from neighbors, thus return false. Return true if exactly one letter is different from adjacent letters. Okay. So here we have two letters that are not similar to any other letter next to them. And here we only have one letter that is not similar to anyone adjacent. Huh. Cool. So we definitely don't want to sort this alphabetically. We do not want to simplify it either, I don't think. Huh. What we might want to do here actually is we might want to simplify down to remove adjacent letters completely. Is my thinking here. So to do that, we would say AAA is equal to A, and then AA is equal to blank, like we did in an earlier puzzle. But we're gonna get an issue if we do that, aren't we? So that will not work. That will not work. Of course, we could do a three-letter check multiple times. We could say, if we have, well, three, no, that won't work either. Huh. How do you do this? My thinking is, huh, this is this is a complicated puzzle. I am barely understanding how it even works. Hmm. There's not a lot of, there's no indentation or anything. There's no if statements, no variables to remember. So you can't count each lonely letter. We need to replace the string somehow. Well, what we can do is we can say that, take the first idea here. Start with this. Now, the issue with this is I would change this out for B, for example. Look at this test string with B's in the middle. The B's would be replaced. I would have A and C next to each other. Now, if the input here was, imagine if the input here was B, and then C, B, A, and then B. We should return false because we have a total of 3 lonely letters, right? This script, it will take the 3 A's, turn them into first 2 A's with its first line, and then the 2 A's into nothing. It will remove this, and all of a sudden, the string that would return false, it will now only have one letter there. These two are adjacent to each other. It will end up returning true. How do you avoid that? What you do is you say that this equals some letter D, a letter that can never be in the input string, so we can treat that differently. Because then this string here, let's see, that was the wrong order. We wanted CB. Instead of removing this and then being true when it should be false, we'll have a D there. And it can still end up equaling false. Now, the reason that is important is we can do this for every letter, right? Like so. And at this point, we should have removed every adjacent letter and changed it out with a D. So what we want to do is, at this point, we want to sort alphabetically, don't we? We do want the string to be sorted to make fewer lines in the future. I don't know, I think that will make things easier for us, right? Because what we can say at that point is so let's do the sorting algorithm again. We know that one. It's CA equals AC, BA equals AB, and then we want to have CB is equal to BC. At this point, we don't need to do anything to sort these. What we can actually do here is, after we've changed every single occurrence of multiple letters in a row to a D, we know that no more letters in a row will be a D. No, we do need... Oh, yeah, we're gonna get an issue here. Sorting alphabetically after the fact will start triggering this earlier program again. So you cannot sort alphabetically, unfortunately. That's annoying. And we cannot remove the D's either. Oh, this is too complicated. This is too complicated. Because what we could do is go through and check every single three-letter occurrence. And that won't even work. Well, what if, at this point, we changed every lonely A to be E, every lonely B to be F, and every lonely C to be G? Now we can sort them alphabetically. After this, we can remove the D's. And since we only have E, F's, and G's, well, these lines won't trigger anymore. And also, this will only trigger on lonely letters because we have already removed all multiples and changed them out for D's. So you can remove the D's, and now we can sort alphabetically. Oh, this is incredible. This is incredible. We can sort alphabetically here, which would be, in this scenario, FE is equal to EF, GF is equal to FG, and GE is equal to EG. That will perfectly sort it in the end. After sorting, we want to check, do we even need to sort? This feels like it's a lot of work for nothing, really. Can we not just check the length of the string here? If we change all of these to be E, then we remove the D, we can just do EE is equal to return false. Exactly E is equal to return true. And then nothing will be equal to return false. Because at this point, we have changed all only letters to E, we have removed the D's. So we'll only have E's left in the solution. And if you have two or more E's, this will trigger, and will not have exactly one lonely letter. It will be false. If we have exactly one E, then this will trigger, because anymore, and we already triggered this. And we can say true. But if this doesn't trigger, we need to return false. If we have no letters left, there are no lonely letters. This should work, I think. Why does this not work? Why would this not work? Test case 10. Can we go to test case 10 here? There should be a way to just go back. Okay, let's just see C B B B C C B B B C C C. And we can just do one line at a time here. So it will change the B's into a single B. Oh, of course that's gonna be an issue. We would want that to be a lonely. Yeah, because this is the script for removing all adjacent letters. The issue is that we'll only end up with one B in scenarios where we have exactly three Bs. That's no good to us. What if we just did... Hmm, how do we get rid of this issue? How do we get rid of this issue? Hmm. Yeah, what can you really do here? If you have exactly three, we won't have an issue. And if we have more, like this is good for even numbers. If we have four, that'll be converted down to two, and then zero with the or D, I guess. But if we have five again, that will be converted down to three, which will give us the same issue. So this is no good. We need to rethink this top bit a little bit because that's not actually removing every adjacent letter. Only even numbers. Only even numbers. That's not good, is it? But how do you work with this? What was it we actually did earlier to get rid of this issue? Because we did have sort of this issue earlier, didn't we? Earlier puzzle. What we can do is, I mean, we could do something like, say, DA and DB and DC. Yeah, that's probably what we do. We just add the original letter here. And then we need... Oh, this is so complicated. So what this will do is, if we have three A's, it will go down to one A, right? No, no, no. What we want here is actually to add the D before these. So three A's will go down to a DA. Now, if you have two A's, that will be a D. And remember, this will always take the leftmost part of it. So sorting these letters like so, if we have four A's next to each other, that will always be converted into DAA and then into DD with this. And if we have five, that will be converted first into DA, the three first, and then we'll have two more, which will be DAAA, which will be converted to a DD. So this should work for every single combination to make them into Ds in the end. The only issue is, say we have exactly three, we will end up with DA and not just D. So we need an additional three lines down here. Down here, is it? Yeah. Which says that DA is equal to, I guess, just D. And then DB is equal to D. And DC is equal to D. And that will ensure that we don't we keep the D's, so we separate letters. So if you have two occurrences of lonely A's, they don't end up next to each other, triggering this line again. But we need to do it before converting the A's, B's, and C's into E's, because obviously this would be DE if we did it afterwards, and that will mess up the rest of the code here. So this will just ensure that if we ever have exactly three or an odd number and went up with DA, DB, or DC, That will get converted down to a D later. This should work now. No? What do you mean this doesn't work? Why wouldn't AABCC work? AABCC. Why does that not work? It first converts it into DBCC. That seems fine. Then DBD. Seems fine. Oh, of course. Oh, because we have a B in the middle. Oh, no, no, no. No, 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 no. We can keep making this more complicated, but I think I'm using far too many lines here. This cannot be the intended solution. It cannot be. It just cannot be. But how else can you do this? So we would need to know whether the dB comes from this or from the original string, which seems just impossible. Unless we use different letters. So in order to not have to redo everything, I think we just do F, G, and H here since they are currently unused. So we say FA, and that's always gonna belong to the A's now. And then we say GB, and G will always belong to the B's. And then we say HC. And the reason we do this is because now we can say FA will be equal to F. I guess we could use D, that will save us some lines actually. Then GB will be equal to D, and then HC will be equal to D. Because simply, like if these A's were B's, we would want to remove the entire B section, and we will do that because we use the same program as earlier, basically. So it will first convert it into GB, right? This BBB. And then later it will look down here, we'll see GB, that will be equal to D, which is correct. That will remove all of the B's, which are consecutive. But in this scenario, right here, which we had issues with now, AA will be equal to F. That will leave us with FB. Now F and B doesn't belong together. It's kind of a parity thing. Like A's and F's are intertwined, B's and G's are intertwined, and C's and H's are intertwined. So if we have FB, we'll not change it. Change it here. And instead, what we can do afterwards here is, and we need an extra step, dude. We can do F equals D, G equals D, and H equals D. And the reason we have these three too is in case we just have a double A. We'll just leave that as an F, and it will never be converted back to a D with this line because we don't have any other A's. We only have two A's to start with. So they should convert everything. This should be good. This needs to work. No? Yes? Well, I think it works. It works. At most 13 lines. How do you remove 6 lines from this? I betcha it's that 2 of these groups are actually useless. Now that we have a basic understanding of things, is there a simple way to reduce the number of needed lines? Is there a simple way to reduce the number of needed lines? We need 2 here for odds and evens, right? Do we know? What we can say is BBB equals BB, can't we? Oh, that simplifies things, doesn't it? Yeah, oh, I'm so dumb. This would have made things so much easier. Oh, I overcomplicated it so much. Because now we don't need these additional letters. This is the script to remove all consecutive letters. I completely forgot. So this will, if we have three consecutives or more, it will keep ticking down until we reach two consecutives. Then we can remove them. Oh, but we do need to tell it to be D. So we don't make a new consecutive pair by removing a random pair in the middle. So you do need to use the D, but we can remove U. We can remove U. That's 6 lines. This should work, right? Yeah. Okay, cool. Oh, that feels so bad. I overcomplicated things so much there. But that's how the cookie crumbles sometimes. It's just how it goes. So yeah, that's all the time we have for this episode today, folks. So thank you guys so much for watching this. I do hope you enjoyed it, and I hope you'll see the next one. And remember, if you want to become a Fopper just like us, do consider hitting that subscribe button. It's free, and it really helps me out. Anyways, have a nice day, and goodbye!